Okay, section 9.2. Let's do another example problem. In this problem, a circuit is given and the problem says at time t equals to 0, the switch is closed, this switch is closed, and the circuit sees a voltage, this voltage source, which is a sinusoid voltage of 100 cosine 400t plus 60 degrees volts. Now the value of R is given. Okay, the value of R is given. Similarly, the value of L of the circuit, so which is this guy. L is this guy and the R is this guy. So these values are given. The problem also gives the equation for total response. When you apply a sinusoidal input, there is a transient response and there is a steady state response. Remember, the focus of this chapter is the steady state response. Okay, the problem gives you the equation to calculate the transient response and the steady state response. Okay, and then we are asked to find the transient response, I transient. What is the transient current at time t equals to 750 microseconds? Similarly, what is the steady state response? Okay, what is the steady state response at time t equals to 750 microseconds? And what is the total response? So we want to begin by finding the total transient response and then finding the steady state response at time t equals to 750 microseconds and then adding them together to find the total response. It's a straightforward problem, as straightforward as it can get. Pay careful attention because I'm going to color code them carefully. Okay? Shown in purple or pink is the total response. That is what we are supposed to find out. And in order to find that out, we need to know the transient response. Okay? If we have the transient response shown in blue and the steady state response shown in red, then we should be able to add both. But look, this guy, all of this is the transient response, right? All of this is the transient response. Let me color code that to fill with this color. Okay, all of that is the transient response, and this guy is the steady state response. Okay, that guy is the steady state response. So if we find out what it is that we are supposed to do, you will realize that if we think about it, it's all a matter of substitution. Let me show you again. Okay, so when we are calculating the transient response, we need a value for Vm. So Vm is given in this guy. So shown in dark green is Vm. So we know this value. Similarly, we know the value of R, right? The parrot green color, the R value is given to be 40 ohms. How do we find out the next value? It's the omega, right? Omega. Omega is given in this equation right here. Okay? Remember cos omega t. So omega value is known. What else? What else do we need? We need a L. Okay, I'm running out of colors. Let's see if you can see this yellow color. L value is given. I'm going to plug in that L value in the equation here. Okay, L value in the equation here. What else? We need negative Vm over r squared plus omega L squared times cosine phi. How do we find out phi? Well, that phi is nothing but this, let's see how I'm running out of colors here. I'm going to pick a, what color should I pick? I'm going to pick a orange color here. So this guy is given to be 60 degrees, right? Then similarly, we know this R is known. L value is also known. Remember, L value is this guy, okay? How about T? T value is given to be 750 microseconds. So I'm going to show this T to be 750 microseconds. So we know that T, and we know just about every other T, okay? Now, the only value that we still need to figure out is theta, okay? In order to find out theta, let me see what other color can I use. I'm going to use this color. I'm going to use theta, okay? That theta can be found out from tangent inverse omega L by omega R. So if we plug all of that in, then we get the transient response, okay? Similarly, so that's for the transient response, shown in blue highlight here, okay? Like that. Like that. How do we find out the steady state response, highlighted in red, okay? That's all of that guy. Think about it. Even in this red scenario, we have the value for Vm, right? Vm is known, which is 100, okay? Similarly, the value of R is given to be 40 ohms, okay? That value of R is given to be 40 ohms. We know omega is given to be 400, right there, okay? And then we know the value of L, right? We know the value of L to be 75 millihenry, because that's given. Remember, that's given. L value is given. Again, we know omega, okay? We know the value of T. You see, T is the value given right here, 750 microseconds. Then phi is given. What color did I use for phi? Okay, for phi, I'm going to use this color, right? I used maybe this color, right? Phi value is given to be 60, like that, okay? So phi value is given to be 60, and theta value, we know how to calculate theta, okay? In order to calculate theta, we use tangent inverse omega L by R. That's it. So at the core, this problem is a matter of substitution. Go by the color code. If you go by the color code, you have transient response in blue, steady state response in red. Let me show that here. The steady state response is shown in red. Okay. Now, all of this guy is the steady state response. Remember, all of that is the steady state response. I'm just going to not fill anything here, okay? That guy is the steady state response. Similarly, this guy is the transient response. So bring out your calculators and plug in the values. Pretty straightforward, okay? So once you do that, you should see a value of I transient Okay, so I transient, I'm going to write it in right here. I transient value is negative 1.2329 amperes. Okay, you'll see that the steady state response is 1.5249 amperes, and both of these are at a time value of 750 microseconds. So at t equals to 750 microseconds, the value of the total response, which includes a transient response and a steady state response, is the sum of these two, right? The red plus blue, which comes out to be I total of 0.2920 amperes. This is what we are asked to find. That's one of the metrics that we are asked to calculate. The second one is this, okay, and then the third one is this. I'm not going to over solve this problem for you. I'm going to leave it here because essentially I have shown you how this problem is really a matter of substituting the values and nothing more. But realize that when a sinusoidal input is applied to a circuit with R, L, and C components, there is going to be a transient response, then there is going to be a steady state response. In this chapter, as we advance, as we look at more and more concepts and theories and examples, we are going to deal with only steady state response. Nevertheless, you know how to calculate both the steady state response and the transient response, add them together to get the total response. All right, so that's it for section 2, chapter 9, example problem.